Ladies and gentlemen, thank you very much to give me this opportunity. It is accidental that I came to see my friend, Professor Muttu. He's next door to me in Melbourne, and he's not here, so I thought that I should do something for Melbourne while I'm here. And then I was told that this is a session for the technology, so I could not stop to talk to you about something which is very important at the moment, is the removal and sensing of the most toxic element, mercury. And India is about 15 to 14% polluter in the global pollution of the mercury. The regulation is going to the United Nations at the moment. The 167 countries are meeting every 6 months to regulate something. Is being vetoed by China and India because China polluted about 54% and India polluted about 14 or 15%. It is a neurotoxin element. 60,000 babies are born in US alone related to the mercury-related disease. Think about India. Now, I was watching the SBS TV about a few days ago in Melbourne, and they were showing that how these pupils in different states of India, particularly in Bombay, is collecting the dust or the sludge which contains gold and try to recover the gold using mercury. Without knowing it, what they are doing. I was contacted in South Africa, a consultant who was asking Suresh, can your technology can sense the mercury in those laser area where the people are doing the unlawful mining of the gold using mercury, amalgams and vaporizing it, so the police can censor it. So I will show you something, because this is some things you will watch in the yahoo.com news. It has gone to the global news, released by the Australian Associated Press about a few days ago. So that is the technology which is came out to the lab, is going to the market. So I will make the presentation small, give you some things that what has been done in there too. So the concept is the nanoengineering. So the concept is there that how we can design the nanoengineering for the different applications. We all are hearing all the times about the nanotechnology. Now this is the life examples where the nanotechnology is showing you the innovations, what it can do. The nanoengineering, as I showed to you, that it is the formation of nanoengineering surfaces, mercury sensing, industrial testing. I was told that I have a test with 10 minutes, so I will cut down. As I was not ready for this presentation. This presentation is ready for a lectures, as a professional lecture to me. So I will just focus on the nanosensing. I will give you a glimpse that how the nanotechnology or the nanoengineering surfaces can sense the mercury and can go to from lab to the marketplace and can help the environment, can help the poor peoples over there too. Forget about it. Just like give you the one surfaces there too. Like for example, what we can do by the electrodeposition method. If you have a little bit of idea of the chemistry of the electrochemistry, you can see there is an electrochemical series. And the electrochemical series, the gold stays on the top. And all the elements of the periodic tables goes beyond gold. So the gold has an advantage to replace the other elements in there too. By doing that, and by the imbalancing the equation over there, we can create the active points on the surface. And those active points are the active points where we can manipulate the properties of the materials for different applications. So that is the one, the goal. And not only that, we have developed a techniques when not only we can do that, but we can block the different faces of the same elements and make it only one face active towards one particular applications. In this case, for example, if you want to deposit the gold on the nickels, we can block the other surfaces, incorporate the nickel 111 by the gold 111. And you can see in there the gold 111 the surface which absorb the mercury the most over there too. In this one, like you see that, this is the unmodified surface over there. The gold is on the gold over there. Is a 15 seconds deposition, 45, 90, 150, and you got these gold flakes. And by using the another chemicals over there, we block all the surface of the gold, allowing only to the increase to the gold 111. And that is the surface which has a unique properties or absorbing this mercury at the different temperatures. At different temperatures to the parts per million to parts per billion level. There too, not only it has a properties to absorb it, but dissolve it as well. Because sensing, when we talk about sensing, we talk about then some things which give you signals that substance is there. But if that substance is not there, the signal should go back to zero. Well, that's the sensing. So that element, that phase of the gold which you use to the noble metals, they use only jewelries and everything, it is a very, very active element, but only to a certain level, at a certain phase. You will not be surprised that gold, which is highly used in India, will be a very reactive element for tomorrow applications in there. And that's the one example I'm giving to you. again, as you can see, that by depositing over there, the gold by the lead, I can deposit. And this is the things. I can do the concentrate. I can make the gold flakes, gold nanoflakes, gold nanotubes over there too. And these golden nanotubes, by approaching there too, they have active sites as the electrochemical CV is showing up. And those two be indicating me, yes, they have active sites. They can do the catalytic reaction. They can do the final productions. They can also do the sensing application, absorbing applications. So that's why we are using those manipulation over there. You can see this is just examples where you the concentration of the lead, where I can optimize the process, where I can have the highest concentration of the lead nanoflakes and the amount of the gold where I can control that. By optimizing the process, I can do that how much the gold I can deposit and which is giving the optimum results over there too. So that's just is the process over there. Different type of oxidation, different, I can also manipulate. I can also manipulate not only just the gold shapes and reactivity, I can relate that. You can make the gold nanoparticles spherical particles. You can make the cylindrical particles. You can make the flakes. You can make the prism, different concentration. As the shape and their design change, the reactivity change. And you can manipulate the shapes. You can also manipulate the reactivity. And that's the innovations over there. That's why how you can convert the different type of applications for your utilizations in there too. And that's you can see that these just the reactions. And I know the audience could not be all the scientific audience or maybe some general interest people. Right, mercury is coming from there, over there too. So that is the main issue you have in there too. You also use the mercury dental, mercury amalgam, forget when the teeth was there, not anymore, but that was there. What is the symptoms, what you do is that learning impediments, memory loss, numbness, loss of the muscles coordination, tumors, tremors, deafness, vision impairment. These are the related to the mercury disease. As you can see, it is an economic activity of $43.8 billion related to that one too. And 60,000 bodies are reported by the EPA USA per year alone. Think about India and China over there too. It is documented in the medical journal as a pink disease, what we call is the acrodynemia. And it is very much related to the India. That's what I'm telling you. And this technology can help. How does it work? That's you have a quartz crystals over there, which is simple formulas. I give you one example over there. Then you have a surface, which is a mono surface there. And you can see as soon as they touch, because the mass change, you start getting a signals over there too. But then when there is no mercury is coming the effluence in there too, then it's go back to zero over there too. But if you have a nano surface, use a modified surface over there. And then you can see that when the surface is modified over there, in their nanoflakes over there too, you can see this sensitivity increase, its performance increase to the 400 times. And that's the inventions we have over there too. In there too, and then you can see that goes back over there too. So that is the simple examples to you that how this sensor, quartz QCM crystals, can act as a good sensor, and it has been tested over the pilot point trial to the refineries over there. It has been tested under the influence of humidity or all those sort of things. It is a proven technology. It is a so much proven technology that the investors are now knocking the doors, and this product is going to commercializations within few months' times over there too. And all these are the scientific, probably the scientific presentation I don't want to present to you, and I can overlook to that too. Just I want to show you the certain thing. These are all the scientific industrial data. You can see up to the 800%, 800% response in the magnitudes by the manipulating the surface over there. So what I'm trying to tell you that by manipulating the nano surfaces, you can tailor design the application, and that is one of the applications which is a life examples over there too. And not only that, it works in the real world examples. These are real world examples. It has been tested and proven in the industrial environment over there. And as my time is running out, I'm just doing the closing remark to you, just trying to get in the end. So you can see who am I, from where I came. And if you want to know more about it, that's the RMIT in Melbourne. Melbourne has been classified the most livable city in the world, 2012, in there too. And so we are in there when we do the research over there. And I must mention to you, yes, I do have a collaborative centers over there in Hyderabad, IICT, where we do the Indian students over there. And we do the PhDs in India with the RMIT PhD over there in the collaboration with the Indian scientist and the RMIT scientist. And the students spend about up to 1 year over there. the purpose is there to produce the Indian youth scientists as a world leaders, and having exposure to the both cultures and scientific infrastructures, both in India and Australia, and the Australian scientists and Indian scientists are working together. And that has been working for last 2 years and has been signed at least for another 7 years too. Last year, I took 70 students over there out of 603. This year, I took 4, about particularly only 3 out of 304. 4 students were selected over there too. And then all the expenditures at the moment is borne by RMIT. So every student has virtually a offer of at least 1.5 crores over the period of 4 years. But they are the selected one. As I said to you, 607, 7, 304, 4. And they are working in the both environments. They are working on the industrial and pollution, water pollution, air pollution, and the nanotechnology, green catalysis type of technologies. And that's why I'm here for doing the international research collaboration. Thank you very much.